Chemistry is awesome! Right, so next is let's look at this question here. And actually guys, so this is your tutorial question, okay, tutorial 1.3, question number 4. Okay, so you can check this question in your tutorial book. Okay, right, so now let's look at the question. Alright, so let's say we have a, what do we have here? So we have a reaction between 7 grams of copper 2 oxide, okay, this is the molecular formula CuO, and 50 ml of 0.2 molar nitric acid produces copper 2 nitrate and water. Okay, and the first question here, A, define limiting reactant, okay, B, write a balanced chemical equation for the above reaction, and then determine the limiting reactant, okay, now this is the one that we are discussing, okay, just now, and then calculate the expected mass of copper 2 nitrate formed, and lastly, determine the percentage yield if the actual mass of copper 2 nitrate obtained from the reaction is 0.85 grams. Okay, so later we will discuss on this, what is the percentage yield. So let's solve for A to D first. Alright.
Okay, so once again, what is the definition of limiting reactant, guys? Okay, the definition. Okay, rest. So limiting reactant is defined as reactant that is completely consumed or used up first, or we can say that finish completely in the reaction, okay, in a chemical reaction. And that is the first definition. Remember, when we want to define this limiting reactant, there are 2 points here. So the first point is a reactant that is completely consumed in a chemical reaction, and the second point that you must state in your definition is this limiting reactant limits the amount of products formed. Okay, so these 2 points, okay, will be the definition of limiting reactant. Reactant that is completely consumed in a chemical reaction and limits the amount of products formed. Alright, okay, so let's move on to the next question, B. Alright, so in B, you need to write a balanced chemical equation for the above reaction. Okay, so let's look back at the question. So we have copper 2 oxide reacts with nitric acid, produce copper 2 nitrate and water. Okay, so let's write the reactants first. So what are the 2 reactants? Okay, so we have copper 2 oxide and nitric acid, and later in this question we are going to determine, okay, between these two, copper 2 oxide and nitric acid, so which one of these 2 reactants will be the limiting reactant and which one is the excess reactant. Okay, but for this question we are just going to balance the equation first. Okay guys, remember, balancing equation is very important, because if you balance it wrong here, okay, you are going to have problem in the next question, C and D. Okay, right, so we have the copper 2 oxide and nitric acid. When these 2 reacted, so what we are going to get copper 2 nitrate and water, and this equation is not balanced. Okay, right, and as usual we are going to start with the most complex substance. So in this case, copper 2 nitrate is the complex substance. Okay, so there is 1 mole copper here, 1 mole copper here. Okay, balance. And then nitrogen, there are 2 moles of nitrogen in copper 2 nitrate. But if you look at nitric acid, there is only 1 mole of nitrogen in nitric acid. So that's why nitric acid, moles of nitric acid, we must multiply by 2, okay, to balance the number of moles of nitrogen in this nitric acid. Okay, and then oxygen, there are 3 times 2, so there are 6 moles of oxygen here. Okay, so 6 moles of oxygen here, and then 6 mole of oxygen in nitric acid, and 1 mole of oxygen in water, and 1 mole of oxygen here. Okay, and then hydrogen, there are 2 moles of hydrogen in water and 2 moles of hydrogen in nitric acid. So the equation is balanced. Okay, it's balanced. All right. Okay, so now let's move on to the question, to the next question. Question C. Okay, this time we are going to determine the limiting reactant. Okay, guys. But for this question, since we have just now we have two options. Remember, we have two options to solve for this limiting reactant. But in this question, I'm going to use the first option. Okay, the first option, which is we are going to compare, okay, reactant and reactant. Okay, we are going to have a look at we are going to compare moles of reactant needed and moles of reactant available, okay, in the reaction. Okay, so first thing first, so in this reaction there are two reactants, and there were two reactants. Okay, so we have copper oxide and nitric acid. So first thing that you need to do is we need to determine how many moles of copper oxide and how many moles of nitric acid used in this reaction. Okay, used in this reaction. Okay, so since we were given just the mass of copper to oxide, which is 7 grams. Okay, so we are going to calculate the moles of this copper to oxide. Okay, using the mass given, and also we need to use the molar mass of copper to oxide, which is 79.545 grams per mole. Okay, so this is the molar mass of copper to oxide. Okay, so from here we are going to calculate moles of copper to oxide. Okay, so mass of copper to oxide divided by molar mass of copper to oxide. So therefore we are substitute the value 7 grams divided by 79.545 grams per mole, and we are going to get 0.088 moles of copper to oxide. Okay, and keep in mind guys, so this is the moles of copper to oxide that we use in this reaction. Okay, so we put aside this copper to oxide. Next, we are going to determine how many moles of nitric acid used in this reaction. Okay, so since nitric acid here is in the form of solution, okay, so we are going to use the molarity given and the volume given, okay, to determine its mole. Okay, so using the formula, moles of nitric acid equals to molarity of nitric acid, okay, multiply with the volume of nitric acid. So we are going to get 0.2 mole per liter times 0.05 liters, and this is the moles of nitric acid used in the reaction, 0.01 mole. Okay, right. Okay, so now we have the two moles. Okay, we have the two number of moles. We have moles of nitric acid and moles of copper to oxide used in this reaction. All right, so next is we are going to determine, so which one of these two, okay, which one of these two will become the limiting and which one is the excess reactant. Okay, so based on the balance equation from what we did in question A just now. Okay, so here I'm going to start with copper to oxide. Actually, if you don't want to start with copper to oxide, you can also use nitric acid. At the end, still at the end of the day, we are going to get the same answer. Okay, but for this question, I'm going to use copper to oxide as the starting reactant. Okay, so from the balance equation, 1 mole of copper to oxide reacts with 2 moles of nitric acid. Okay, and we don't have 1 mole of copper to oxide. So how many moles of copper to oxide that we use in this reaction? Yes, here guys, 0.088 moles of copper to oxide. So therefore, if we are just using 0.088 moles of copper to oxide, So this copper 2 oxide should react with 0.176 moles of nitric acid. Why? Because the ratio is 1 to 2. Okay, so that's why this is the moles of nitric acid needed to react with 0.088 moles of copper 2 oxide. And do we have this amount of mole of nitric acid? So now let's look back at the moles of nitric acid that we have. Okay, so we have 0.01 mole of nitric acid, and this is the moles of nitric acid needed to react with 0.088 moles of copper 2 oxide. Okay, so moles of nitric acid needed is 0.176 mole, but we only have, or we can say the moles of nitric acid available is just 0.01 mole. So if we compare these two, if we are comparing these two, moles of nitric acid available is less than moles of nitric acid needed. So what does this mean to you? Yes, so this means nitric acid is not enough to react with 0.088 moles of copper 2 oxide. So what can we say about this nitric acid? Yes, so nitric acid is the limiting reactant. Or we can say that copper 2 oxide is the excess reactant. Okay guys, so clear? Alright, good. Okay, next. Right, so next is we want to determine the mass of copper 2 nitrate formed in this reaction. So since copper 2 nitrate is the product here, and remember in the definition of limiting reactant, reactant which is completely consumed in a chemical reaction. And remember the second point in the definition of limiting reactant, what is it? Yes, it limits the amount of products formed. So that's why in this question D, here, in order for us to determine the mass of copper 2 nitrate, so we need to use the moles of nitric acid, used in the reaction. Why? Because nitric acid is the limiting reactant. So that's why the quantity or the moles or the mass of this copper nitrate, greatly depends on the mole of this limiting reactant, which is nitric acid. Okay guys, so now let's look at how to solve this problem. Okay, so once again, since we knew that or we have determined that nitric acid is actually the limiting reactant, so this nitric acid will limit the amount of copper 2 nitrate formed in this reaction. Okay, so from the balance equation, so we knew that 2 moles of nitric acid here produce 1 mole of copper 2 nitrate, but we don't have 2 moles of nitric acid in this reaction. We only use 0.01 mole of nitric acid, so therefore it should produce 0.005 moles of copper 2 nitrate, and this is the moles of copper 2 nitrate produced in this reaction. Right. Okay, and then we are going to determine the mass of this copper 2 nitrate produced in this reaction. Okay guys, alright, so we are going to use the molar mass of copper 2 nitrate, which is 187.56 grams per mole, right? Okay, so mass of copper 2 nitrate, right, equals to moles of copper 2 nitrate times molar mass of copper 2 nitrate. Okay, so 0.005 moles times 187.56 grams per mole, and we are going to get 0.9378 grams of copper to nitrate. Okay guys, so that is the mass. That is the mass of copper to nitrate produced in this reaction. Okay.